Okay, so we are going to do this complex fraction problem. However, I am going to assume that you know what an equivalent fraction is, how to get it, and I'm going to assume you know how to simplify crossways and from the numerator and denominator. So I'm not going to do all those steps to show you. But in order to get, so we're going to go right into this and solve this out. So complex fraction, there's a fraction on the numerator and a fraction on the denominator. I solve each of the, or simplify each of those as much as possible, and then I simplify the result. So I take the numerator, I'm going to simplify this down. I notice here that 20 is going to work as a denominator. So I'm basically going to say 4 times 5 is going to be 20, which is what I want. So 5 times 1 is 5. 4 times 5 is 20. Minus, I'm going to say to get 20 here, I need 4 and 4. So I have 8 20ths, which gives, now they're common denominators. So I go 5 minus 8 is negative 3. And then we have 20 on the denominator. So here we go to this one. Now I can make the 3 a fraction by simply putting it over 1 minus 1/3. 3 will be our common denominator. I don't need to do anything to get this one to get it to be that. So I'm going to multiply this by 3 on the numerator and the denominator. And I have negative 9 thirds minus 1/3. So negative 9 minus 1 is negative 10 third. So this gives me negative 3/20 divided by negative 10 third. So we write this in a more customary way. Negative 3 over 20 divided by negative 10 over 3. And we keep this. So to solve this out, we keep, or simplify this, we keep this the same, this first fraction, change the division to multiplication, flip this fraction over to 3, negative 10. I look to see if I can simplify or reduce anywhere, and I cannot. So I will multiply straight across. So negative 3 times 3 is negative 9. 20 times negative 10 is negative 200. These are both negatives, so they basically cancel out, and I am left with 9 over 200. Now, if there's any step in this that you do not understand how I got or did, I have a longer video with all the steps more clearly written out. Why do we care about stuff like this in pre-calculus? The reason is because we are going to be doing a lot of things like this with polynomials and binomials and all those fun things that you've worked with in previous classes. But the concept, how you do them and what you do, is the same as this. So when you start running into those higher things, numbers, forms that we look at, you can always, if you're confused, come back, think to yourself, or look at one of these videos and see, how did I do it with numbers? And then you look at that and go and tell yourself, the way I'm going to do that is the same as the way I did this. It's just I may have algebra in there with variables and multiple terms, but it's going to end up being the same process. And that is a strategy of learning and solving and doing these things, or in this case simplifying all these things. And so we want to know these strategies and remember them so that we can apply them to binomials and even more terms having polynomials.